Hi, this is the last video of section A for the cardiac system, and we're looking at changes in pH, diffusion rate and the arteriovenous difference. So let's look at changes in pH first of all. A normal blood value pH, which by the way refers to the acidity or the alkalinity of the blood. So a normal value is number 7, which is a neutral value. If we're going to be specific, you're going for those distinctions, then 7.2 to 7.5. But from the exam papers that I've seen, pH of 7 is fine. So as you exercise, the pH of the blood decreases slightly, and this decrease in pH means it's becoming more acidic. If you work out harder to a higher intensity, so instead of going out for a jog, you start doing hill sprints, then as the intensity increases, you'll find that your blood becomes more acidic as time goes on. So what causes these changes in the pH of the blood? Well, as I mentioned before, there's differences in the acidity for low to moderate intensity exercise to moderate to high. So let's have a look at low to moderate first of all, where the pH is still reduced, and this is down to increased carbon dioxide. So let's imagine we've gone out for a jog, our breathing rate has increased, our heart rate has increased, but we're at a steady pace. We're going so we can hold a conversation, so we're in moderate activity. Our working muscles are producing carbon dioxide through the Krebs cycle, which we'll learn about later on in a section A7. This carbon dioxide has to be released. First of all, it comes out of the working muscle, out of that muscle cell, and it gets put into the bloodstream via those capillaries. When it's in the bloodstream, it doesn't stay as carbon dioxide, it turns into carbonic acid. And obviously the name gives it away, doesn't it? So it's going to reduce the pH of your blood. If you work at higher intensities, so we're not just using the aerobic system, but you have to then start to rely on these anaerobic systems, these systems that don't require oxygen, because essentially they're a bit quicker. You get different byproducts. So you don't get carbon dioxide, this time you get lactic acid, which you would have probably all felt when you've been doing some sort of high intensity exercise. Think about a ski sit against the wall, something like that. That will reduce the pH even further. And again, it's produced in the working muscle cell, but it doesn't stay in the cell. It gets expelled from the cell into the bloodstream via those capillaries. And when it goes into the blood, it now forms lactate. That's the one we're interested in at the moment, because that's the and hydrogen ions, which we'll learn about later in A7. But they will reduce the pH of the blood further to make it even more acidic. So it's lactic acid produced in the working muscle cell, but as it gets expelled into the blood vessel, it separates into lactate. So let's move on to diffusion rate this time. Diffusion rate is referring to the speed at which oxygen is taken from the alveoli into the capillaries, and the carbon dioxide is released back into the alveoli. And it's also looking at the speed at which this oxygen is passed over to a working muscle, and the working muscle is able to give out that excess carbon dioxide. So it's diffusion rate, and we're looking at two sites specifically, the lungs and the working muscles, or the alveoli and the working muscles. If you have an excellent network of capillaries, so you're fit and healthy, you do lots of aerobic activity, and you have grown more capillaries around the outside of the alveoli, you will have a greater surface area for diffusion. If you've got more places where diffusion can occur, then the diffusion rate in itself will increase, because you will be more efficient. You'll be able to exchange that oxygen and that carbon dioxide a lot quicker. So during exercise, more oxygen is required at the working muscles. So we're looking to take more oxygen from the alveoli into those arteries for delivery. Equally, more carbon dioxide is produced by the working muscles, and we need to get that out. If we can exchange these two gases quickly, it has a big impact on our capacity for exercise, meaning if you have an efficient and effective diffusion rate, a fast diffusion rate, we can work at higher intensities for longer, so we could probably be more successful in our sport, and we can work at higher rates. Oh, I said that for longer, so the duration we can work out for longer. So let's. Okay, we finish off with arteriovenous difference, AVO2. So the A stands for arteries, this stands for veins, and this stands for oxygen. So we're looking at the difference in oxygen content between the blood in the arteries and the blood in the veins. So they will also refer to this as arterial blood and venous blood. So arteries, those big muscly vessels, carry oxygenated blood from the heart to the body, and the veins, although they can be quite big, they're not particularly muscly. They carry deoxygenated blood from the body back up to the heart, and then from the heart onto the lungs to get reoxygenated. This should be a recap for Unit 2 for you. So we know that the working muscles use oxygen, and the more they exercise, the more active you are, the more oxygen you're going to use. Now it takes that from the arteries. So that means when the blood is coming back from those working muscles via the veins, there'll be less oxygen content. So on the way to the working muscles, you've got a very high content of oxygen, and on the way out of the muscles, you've got slightly less. Now, how much is dependent on the intensity of the exercise. So if you're exercising very hard, then you'll have a lot less. If you're doing light exercise, it'll just be a slight reduction. So we're going to try and interpret some numbers here, and this was in an exam paper. So could you have a pause of the video and write down why the numbers change between this rest and exercise? Have a go. Tell me what the table is showing. I've put that right. I hope you've got it right. We'll see. I'm sure you have. So let's have a look at the numbers. This number here represents the difference between the blood in the arteries going to the working muscles and the blood in the veins going back up and away from the muscles. So it's looking at the difference between these two vessels. So we can see here that the difference when resting is only 4. So that means that we're getting plenty of oxygen to the working muscles, and we're still getting plenty of oxygen coming out. So the difference is only 4 millilitres per 100 millilitres. If we start to exercise, this number can go up to 15, look, and that means that we've got the same amount of oxygen going in, but we've got less oxygen coming out. So the difference between the two is much greater. So there's a difference because we've used that oxygen in the muscle cells. So that is what the table is showing. So if we look here, we're going to have high numbers during exercise, and the more intense the exercise, the higher the number. The high numbers can show intensity of exercise, but also greater efficiency, and that refers to the athlete themselves. So if the athlete has a lot of capillaries around the working muscles, then they're able to distribute more oxygen into that working muscle. So therefore, it stands to reason there's less oxygen going back up through those veins. So you've got the same, or different people, working at the same intensity for them. So not the same speeds, but the same intensity for them. The same RPE, perceived rate of exertion. So they're working at the same level, but one person's differential number here between these two
is much greater than another person's. So what that means is one person is able to utilise more of that oxygen than another person, and that is because the one person who's got higher numbers has got more capillaries. So if you've got a bigger surface area for diffusion of these gases, then more oxygen can be diffused across in the same period of time, and that's what makes somebody more efficient when they're an athlete. So we've finished section A4 now. If there's anything you're not sure of, go back and look at the tutorials, make your notes, test yourself, and do all of the tasks, please, on your OneNote. Thank you.